Hello, good day. Thanks for joining me. This is Adobe Fikemba. In this channel, I told you I'm going to be teaching you physics, chemistry, biology. Today, we're going to be learning chemistry. Go watch chemistry parts 1, 2, 3, 4, 5, 6, 7, as the case may be. So, we're learning chemistry today. And we've been dealing with separation technique all the time, all the while. So, we're looking in today's class in chemistry, we're going to be looking at number 1, crystallization. Okay, we're going to be looking at crystallization. We're going to be looking at recrystallization, and we're going to be looking at fractional. So let's look at fractional crystallization before we're going to be looking at crystallization, fractional crystallization, and recrystallization. Okay, this is what we'll be looking at today. Now, what is crystallization? Take note. Crystallization is a kind of separation technique that involves obtaining a solid from a saturated solution. So, number 1 point about crystallization, it has to do with it's used to obtain crystals, especially pure crystals, okay, from a what? Saturated solution. Saturated what? Solution. Okay. It is used to obtain crystals from a saturated solution, pure crystals from a saturated solution, or it is used to obtain solids, okay, solids from a what? A saturated solution. Is that clear? Another point you need to know is that number 3, it is used to obtain salts that can be destroyed on eating. Okay, it is widely used to what? Obtain salts that can be what? That can be destroyed or decomposed. Destroyed or decomposed on heating. That is what crystallization is used for. How is this done? In this case, the solid or the salts to be obtained. Now, in this case, the impure solid in crystallization, the impure solid is placed in a solvent. Okay, so I'm going to clean this. Hold on. The impure solid, I'm going to clean this now. I want to explain how this thing is done. So the impure solid, take note, A, impure solid is what? Dissolved in a solvent. Now, the impure solid is dissolved in a solvent, and then what happens? It is heated. Okay. Now, the essence of the heat is to make this solvent to do what? Evaporate out of the solution, leaving behind this solid solution. Now, on cooling and drying. On cooling and drying. When we mean cooling, we mean after you've heated, now no more heat is being applied. That's where the cooling comes in. Then drying, okay, you dry it. Then what happens is that a pure crystals or solid is what? Is formed. That is how crystallization separation technique method takes place, so that to obtain a solid of a purer form. Is that taken? Now quickly, let's look at the next one. Fractional crystallization. Okay, I'm going to clean this now. Fractional crystallization. In the case of fractional crystallization, it is used to separate 2 or more salts. Number 2, fractional crystallization. Fractional crystallization. It is used to separate, take note, used to separate 2 or more what? More salts with different what? Different solubilities at different temperature. Very important. At different temperature. Okay? At different temperature. This is what makes this a little bit different from crystallization, but they are all similar processes. They are also dissolved in a solvent, and at the end of the day, when they are heated, cool and dried, what happens? You will see that solid substances, salts, okay, salts that are in a solution can be separated using this method, 2 or more salts. Now, in this case, these 2 or more salts, they must, number one, have a what? Different solubility. That will take me to recrystallization. They must have different solubility, and this different solubility must take place at different temperature. What does that mean? It means that at a particular temperature, 1 or more of the salts must be soluble. Okay? At a particular temperature. They must not be soluble at the same temperature. Otherwise, it will be very difficult. Let's say if you have salt A, salt B. Okay? When you heat both of them, you understand what I'm saying? When you heat them in a solvent, you see that salt A becomes soluble when it is 20 degrees Celsius, for example, and salt B becomes, let's say, 50 degrees Celsius. At this point in time, you will notice that their solubility is what? Different at different temperature. So that will make separation very easy. So fractional crystallization has to do with the separation of 2 or more salts with different what? Solubilities at different temperature. Now, when we talk about different solubilities here, we're also talking about some can be soluble when it is hot and insoluble when it is cold, as the case may be, and vice versa. So this is what fractional crystallization is all about. And it is used to obtain salt of purer form. It is used to do what? Obtain salt in a purer form. And lastly, you want to look at recrystallization, which has a relationship with this one we just looked at. Recrystallization. What is recrystallization? Okay, it involves, recrystallization, number one, involves choosing a solvent. Okay, choosing a solvent in which the salts to be separated are soluble in. It involves choosing a solvent, that's number one. Number two, in which the salts, okay, or the solids to be separated. Choosing a solvent in which the salts or the solids to be separated are, number three, soluble in it. Soluble in this solvent, soluble in it. Okay? They are what? Soluble in it. Are you with me? Soluble in it when it is hot. And, let me write here so that you can see. And insoluble when it is cold. The essence of recrystallization has to do with redissolution, okay, of the salt in the solvent. The very essence is so that you can obtain salt of a what? Purer form or higher purity. Higher purity. The essence is to obtain salt of what? Higher purity. And mind you, both crystallization, fractional crystallization, recrystallization, the very essence of carrying out this type of separation technique is to obtain a very pure form of that solid or of that salt. And that is why this kind of separation technique is very, very much predominantly used in the pharmaceutical industry. Pharmaceutical industry. Okay? For manufacturing of what? Drugs. Of course, you know, anything that has to do with medicine has to be in a purer form because it's going for healing and all that. So, pharmaceutical industry will use this method for the manufacturing of drugs. Also, another industry that will use this one is also a food industry, okay, that will manufacture what? Sugar. You see it now? So, sugar industry and the pharmaceutical industry will carry out what? This crystallization method as a separation technique. The very essence is so as to obtain salts of what? Of purer form. Thank you. See you in the next class. If you're not following me, I'd like you to follow me. I'd like you to subscribe so that you can get more videos. We can learn together. I just want you to understand. Thank you.